Hello all, welcome to my channel. Uh, in this video, we will be seeing the uh, remaining concepts that we were discussing in the previous video. Like we had covered till auto compaction. Now we will move ahead with other topics that we have at our hand. So let's get started. So in last video, we had seen how we can do auto CDC and everything with delta live table. Then in this video, we start with auto compaction. So auto compaction is a maintenance activity that we have to perform on an open table format. So auto compaction, like I said, we have different ways we can do table maintenance in Databricks. We have optimize plus G order, we have optimize writes, and then we have auto compaction. So auto compaction combines the small files that are there within delta table partitions and automatically reduces the small file issues. It also uh, has some it runs synchronously on the cluster that has performed the write. So auto compaction only compacts that file haven't been compacted previously, so it will not do a full rewrite or something like that. So and we can enable it at a table property saying that delta auto optimize auto compact to true, or from Spark session we can say database.delta auto compact enabled to true. So that way we can do auto compaction. Then we have auto CDC. So auto CDC APIs are recommended way to handle change data capture that we were discussing in the previous video. We have change data feed for the files, but also we can use CDC APIs to apply the changes that are there in the Delta pipelines that we have. So what we can do is it is faster. Why we need to do is that apply changes method, which was there earlier older method. This auto CDC APIs improves upon that by making it 40% faster. It also had lesser memory, what you call footprint. Its throughput is more, 60% more. And this is how we define uh, CDC approach. So we have a delta table, which is DLT, delta live table that we have defined, and then we say create a CDC flow of this. So we say source is order stream, target is orders final, on what key we will be doing the CDC, and then sequence and everything. And then once we have defined this, we can use it I mean we can use it as a way, or we can define it as a SQL as well. So while creating auto CDC in here, we'll say create flow called order finals as auto CDC into and then we provide the destination table that okay, we want to insert into this table. So this is what the target is, and the source will be somewhere in here. We have order final final stream. So this is where we say stream. So the cdc.data stream will be the order stream. So order stream is the source, target is there. So this is how we define an auto CDC. Delta engine is Databricks' own optimized query engine that speeds up the SQL and data frame operations on Delta Lake. It is built to handle large data sets. So this is, but now I don't think it is being used that much. I think Photon and other compute warehouses are working better. Then we have a concept of dynamic partition override. This is only available in database. That's why I mentioned that we should be looking at this as well. Dynamic partition override is a mode which automatically decides which partitions that I have to rewrite to. Users don't have to explicitly mention the partition. It will, based on your command, it will find out which partition that needs to be rewritten, and it will only write logical partitions that does not means that does contain the change. If there is no change in that particular partition, it will not be rewritten. So these were the concepts still which were used for the data engineering. Now let's see some of the concepts which are there in Databricks for ML. So ML Flow is an open source platform for managing end-to-end machine learning lifecycle, and Databricks offers this ML Flow as a managed offering in Databricks and unified intelligence platform. It allows us to build ML application. Now we can also build a generative AI applications using this. So it allows us to do model tracking. It allows us to create models. It allows us to store the models in model registry, and then we also can create AI agent evaluation and tracing using this ML flow. So ML flow is kind of an end-to-end, and it is widely supported by the community as well. It has a large user base. and the people who use ML flow outside of Databricks as well do contribute to it. So it's a good project and it's a good offering in Databricks. Then we have AutoML, which simplifies the process of creating the machine learning by end-to-end using our data sets. So it can do automatic cleaning of data. It can orchestrate the distribution model training, hyperparameter tuning, and everything. It also finds the best model using the open source evaluation algorithms from, let's say, we decide that I want to do based on, let's say, the 5 models that we have, like scikit-learn, XGBoost, GBM, Prophet, or ARIMA. So these, out of these, it will automatically choose which one is best for our use case and then present the results. And then based on that, we can use this to decide or fine tune our model, selected model. Then we have AI Gateway. This is a new offering which is quite recent that it was launched. It allows us to run, secure, and govern AI traffic that comes on the platform. So it is built on top of Mosaic AI, Mosaic company that they acquired. So it has a rate limiting option. It has payload logging. It allows us to track usage. It allows us to add AI guardrails and stuff like that. So this is kind of a two-way engine. So one is the model serving UI, and then there is a gateway dashboard. So what happens is we have data in Unity catalog, or we'll say we have feature in feature serving modules, and then those gets into the model training. Then the model management happens at model registry or Unity catalog level. Then it goes to production in terms of model serving and batch inferences, and then lake house monitoring, detection, and everything. So those are the components of AI gateway, but there are other components powered by Mosaic AI in Databricks, which is vector search, agent framework, model serving, feature store, and lakehouse monitoring. So these are some of the components which are built into Databricks system once they acquired this company called Mosaic AI. So the whole system is like this. Then uh, they have some offerings in AIBI dashboard, AIBI Genie, which is their new offering, which allows us to do business teams to interact with their data in natural language. For example, it's kind of an what you call, it's a kind of an generative AI system built on top of customer data. So it understands your queries, translates into a SQL, or uh, it can create dashboards for us. It can create write SQLs for us. So this Genie, it provides a conversational interaction powered by Databricks advanced AI capabilities. It gives immediate insights, and it is a personalized analytics based on user context and preferences. Then we have dashboards. So this is visual and intuitive access to data-driven insights. These dashboards leverage Databricks SQL, MLflow, and Data Lake to deliver real-time analytics and predictions. It is very interactive, and it has enhanced decision making with actionable insights as well. Then we have Lakebase. This again is it's something which was recently acquired by there was a company which was acquired by Databricks, and then they on using that they have built a system called Lakebase, which is nothing but a managed Postgres system, Postgres database, which will offer them an OLTP kind of workload. And this is something that the companies use. I mean, Databricks is trying to unify the lake house as well as the OLTP platform. So let's say if you have something that you have built using the lakehouse platform, but you want to serve that as an point lookup kind of queries, or let's say you have an UI which is being powered by the analytics that has been done, but you can't give that analytics in from the warehouse. So you have so what you will do is you will aggregate the data and put it into a PostgreSQL system, and that PostgreSQL system will be or either exposing an API, or it will be giving the access to the application to consume the insights in the point lookup manner. We can find out, or row by row kind of work that we have, we can do it using Lakebase. So yeah, these are there is one more suite of family of products which is called the Lake family. So I have a different video altogether. I will add a link to that video in this video description, or in the info button. that has lake flow, lake jobs, lake pipelines. So all things related to lake is mentioned in that video. So if you are interested, go and read that video as well. So that was it for this video. Thanks. Have a nice day. And if you like these kind of videos, do support the channel and suggest what you would like to see next in the comments. Thank you.